This is Prashant, Mohan, Thakur, and welcome you all to Competition Valley. We are doing yet another video on number system. Although in this class we were supposed to go for our next concept and next subject, next topic, but I decided to take one more extra video so that we can do some good question and we can revise this, because this is a very important topic, what we have been doing in last three. So you would need continuous revision on them. So that's the reason I'm doing another couple of questions, and then in the next video we'll be going for divisibility and other things. Okay, so let's just go through the video and repeat it. Just do those many questions what I've been telling you. If you have time, do any other questions as well, but if you are in lack of time, just revise these questions as well. These questions have all the concepts which already have been asked, and these would be repeated again, in coming UPSC CSAT or in coming CAT examination. You would have all these questions, and most of the questions that we do, these are based on those parameters itself. These questions are no less than, and sometimes we repeat their question. I just want you to give an impression that it's not that you cannot do it, or you cannot go for a CAT question or UPSC SAT question. You can just solve them like this, in a snap of time. So let's start. I'll be doing some questions. So let's see where to start from. Okay, so what we can do is, let's say there's a number n equal to 2 to the power 6 into 5 to the power 5 into 7 to the power 6 into 10 to the power 7. So how many factors of n are even? Just think about it again. We have already done these questions before. N into 6 into 5 into 5 into 7 into 6 into 10 to the power 7. So there's so many ways that we can do this. So but because we have already done these sort of questions before, so we'll be taking the fastest route. So again, we can see it is straight away asking for even, and we know that even numbers, we have studied this so many times now, are in 2k form. So what we're going to do, we are taking 2 away from here. Whatever is left behind is okay. Now, okay, yeah, it's a very good thing over here. So let's start. 2 5 into 5 5 into 7 6 into 10 to the power 7. Now if we go about doing the same way, we would end up in trouble, because over here this number is not the prime base. So before we proceed, we need to ensure that all the numbers, all the factors are exactly in the prime base thing, and that was my intention, and that was the reason I put this question up, just to ensure you, just to remind you, so that you now you have heard it, so you would always remember it. So first of all, what we're going to do, we're going to break this n equal to 2 6 into 5 5 7 6 into 2 7 into 5 7. So this will give us 2 13 into 5 12 into 7 6. Now this is very simple. This is into prime base. So what we need to do, we need to take even number. So we all know even numbers are in form 2k. So we need to take 2 out of this section. So we would have 2 12 into 5 12 into 7 6. So therefore required number be 13 into 7. So it should be 91. So 13 13 13 39 178 118. Again, this is a CAT question. See, it just took a couple of seconds. I'm just doing these steps so that anyone who is new onto the video, they can get to know about how it has been done. Otherwise, you can straight away do it from here itself, mentally. Everything can be done mentally if you practice it. Now we'll go for the second question. Again, numbers A, B, C and D have 16, 28, 30 and 27 factors respectively. Which of these could be a perfect cube? That's the question. We have discussed this topic before. I'll repeat again. What does a cube mean? That it has to be in this form. Okay. Now there are certain important concept of cube that I'm going to present over here. That's one of the reasons that I picked this question. See, it says number A, B, C, D have these many factors, and let's say which of these would be a perfect cube. So first of all, it's not given if the number A or B or C or D are single digit, or is it 2-digit number, 3-digit number, or what are the basis of these numbers. But still, just by using our concept and common sense, we all know that the smallest perfect cube would be 27, because, or 8, before that 8, and after 8 it will be 27. Okay, so this is pretty simple. We can figure it out from here as 2 cube and then 3 cube. Now it says that A, B, C, D have 16. Now this is very important. This part will be used over here. Okay, so A, B, C and D have 16, 28, 30 and 27 factors. So let's consider this over here. It could be, let's say that 16, if it has a 16 factors, what do we mean by that? Either it could be something x to the power 5. If it is x to the power 5, we can do x to the power 5, x to the power cube. Either this could be the case, because it says x to the power 15. Similarly, if we take 28, it has to be x to the power 27. For 28, it has to be x to the power x to the power, it's a cube. Yeah, it says 27. I'm sorry, it is, yeah, I'm taking this 27 now. Okay, so I've taken 16. So if I take 16, it would mean that x to the 15, so it's x to the power 16 actually. Let's do it again, hang on. So where we started, that first of all we don't know if A, B, C, D are or these have how many digits. Okay, so we would keep going on till the time we reach these many factors. So let's start with A. A has 16 factors. Now we know that for anything to be cube, it has to be multiplied 3 times. It has to be in a pair of 3. So what we can do over here is, let's see, 16 factors. So if we consider single digit number, because we don't know first of all if it is a single or a multiple digit number. So if it is a single digit number, so it is 8 for example. Okay, so let's say it has 16 factors, which is again sort of impossible thing, but still I'm taking an assumption. I'm looking for reasons that why we cannot take 8. So 8 is 2 cube. Okay, so which of these can it be a perfect cube? It cannot be, because if it is 2 cube, so the number of factors it would mean is only 4. So it cannot be a single digit number. Not be a single digit number. Why is it so? Because if it would be only a single digit number, then it would mean that the number of factors would only be limited to 4. However, we see that A has 16 factors, so it's certainly not a single digit number. So someone may ask, why not 15 to the power cube, anything else? Because why not? because as if now we are trying to look for the cube root. So the smallest cube, a perfect cube, because it is asking for a perfect cube. So the smallest one is 8. So after 8 we have 27. Okay, now 27 is 2-digit number. Okay, so what we can assume over here, because since 27 is 27 is a two-digit number, so we may see that we may assume a 2-digit number. We may assume a 2-digit number PQ. Now for it to be the perfect cube, it has to have 3 and 3. It has to have power of 3 on P and power of 3 on Q. So what we see, if it is as such P3 and Q3, then the total number of factors that PQ would have is 16. No, wait, again, just focus again. When we were doing this 8, we saw that 8 comes to cube, or we can consider it as PQ, but the number of factors it would have is only 4, isn't it? How? See, 2 cube means 2 0, 2 1, 2 2, and 2. Would have only, but what does it say? It says that A has 16 factors. So certainly it cannot be a single digit number. Now we are assuming a 2-digit number PQ, because after 2 all the perfect cubes would be above the single digit number. We assume PQ, so we see that for any 2-digit number to be a cube root, they must carry a power of 3 over here on their basis. So P3, Q3, and then also the factor has to be 16, which is, so I can be very sure that 16 is one of those numbers. 16 is one of those numbers which is perfect cube, isn't it? Let's look again. Any doubt, straight away email it to me. I'm available all the time. This is what I'm doing nowadays, nothing else. Now let's check for B. It says B 28 again. Now we have, in the first process only, we have discovered that B, A, C or D are 2-digit numbers. So again PQ. Okay, so 3 3. So we see that we have discovered that A, B, C, D are not single digit number. That's what we have discovered. Okay, I beg your pardon. We know that right from our first observation. We know that A, B, C, D are not a single digit number, as it does not fulfill the criteria of number of factors given. Now again we see over here that it's not fulfilling for a 2-digit number. So can we look for a 3-digit number as well? So can we see over here as R, and can we put over here is 3. Now what do we see over here? So what do we see is that, okay, let's see, 4 4 4. So 4 into 4 into 16. The 4 is 64. Hang on. 64. Again, B has a factor of 20. B has 28 factor itself. So it means we cannot take this one. So let's see if we can do something else. P and Q. So can we do something like this? 3. So it will be 4. And can we do over here 6? So if we have something like P cube and Q6, can we convert it over here as P cube, then Q cube or Q squared into cube? So it's AB cube. So what we can do over here is that this way we can write it down over here. So 28 can be written in this way. So we can have a number, 2-digit number again, P cube and Q6, and we would have 4 into 7 equal to 28. So we can be very sure that this also is a cube. Okay, now again, see where we have a 2-digit number. Why we cannot have a 3-digit number? Because the moment we go for a 3-digit number, that's the base minimum. So the number of factors it would have is 81. Okay, now we can check this as well. So let's say PQR, and we have PQR is a cube root. Okay, so 4 into 4 into 4, it has to be 64, right? 64. Okay, so that's the reason. We can try checking this as well. How many factors do we have? 1, 5, and then 15, I believe. No, not 15. 5 into 5 into 5. That's what it is. So it's not. Okay, this might not be generalized then in this case over here. But if we take as per the given question, if it says PQR, so it has to be 64 factor, but over here it's only 28 factors. So what we can do, we can write over there this as well. Now we can check the same for C as well. For C equal to 30, so again we can let's see if we can write anything. P or 30 means we need to have 5 into 6. So what we can, so for factor to be 30, it has to be in P4 or it has to be Q5, because then only you would have 5 into 6, 30. So you see that it's not fulfilling, because we cannot break, you cannot write P4 in form of P4, P to the power 4 cannot be written, or we can say any number to the 4 cannot be a cube root. So that's why this number 30. So C certainly is not a perfect cube. And then we can check for 27 as well. For 27, let's see. Again, we know it's 2 digits. So for P and Q, for 27, it has to be. We can check for 27 to be a factor. If it is 2-digit number, it seems to be one would have 8 into 2. So you can have, this would have 27 factors. So P8 can be written as, no, P8 cannot be written as, again P8 cannot be written, P8 or Q squared can't be expressed as perfect cube. Okay, so this is also not there. So we can remove this. So the answer would be 16 and 28. Okay, I'll just repeat what we have done over here once again so that it's much clear. Actually, it's a very easy question. Okay, it takes time to explain things, and it takes time to understand things as well. So again, see, A has 16 factors. 16 factors, and we need to check if A is cube or not, and we know cube are in the form of e to the power 3. It has to be 3 and in that form accordingly. So what we can do over here is, so we were checking for 16. So for 16, and we know that it cannot be a single digit number. We have observed that, because for a single digit number, this power would never be 16. Okay, so let's say P and Q are a number. We need to see if we get anything nearby 16. So we know that if we get P as a cube and Q as a cube, we have power, you get factor 16. When P and Q are cubes, perfect cubes, you get power as 16, which makes A as perfect cube. Again, when we go for checking 28, so we see that P and Q, and what do we need? We need 28. So we know that if we do 6 over here, and if we do 3 over here, so which means Q is anyhow a cube, and now we need to check for P. So P6, we are writing, let's say 2 into 2 into 2 into 2 into 2 into 2. So what we can write over here? We can write over here is 2 cube into 2 cube. So it is 26. Okay, so it's actually cube. So like what would happen over here? 64. 64, if you try to write in is 8 square. If you want to write 64 in 2, it will be 26. So that's the difference what I'm talking about. So in prime form, if you write, this is what will be. So that's why it can be considered as cube as well. So you have 30, and this gives B as perfect cube. Now same with 30. The C option is 30. We need to consider for 30. For 30, what do we need? So for 30, we would need P to be and Q. So we would need for 30, we would need, if you take 1 3, it will be 10. So certainly it's not going to we can take 9 and 2 over here, but if we take 9 and 2, we get 30. But then Q square, it's coming Q square, it means not a perfect cube. What other option we can take for 30? We have taken 10 into 3. We can take 2 into 15. No, that's not going to happen as well. We can take any number we can take over here. We can take 5 into 6 or 6 into 5. So again, 5 over here is not cube. So actually it's not forming cube. And the same is with 27. Okay, we're trying to check for the factors. It's not happening, so it's not cube. Simple. Now we'll do one more question, a very standard question. 3-digit number ABC has 3 factors. Okay, how many factors does the 6-digit number ABC would have? Again, ABC has 3-digit factor, and we need to check for ABC. Now focus. Okay, so can we write ABC in form of 10 to the power 5 into A plus 10 to the power 4 into A plus 10 to the power 3, oh my mistake, it's B into C plus 10 to the power into A plus 10 to the power 1 into B plus 10 to the power 0 into C. Nothing wrong. We have read this, 10 to the power 0, 1, 2, 3, 4, 5. We have read this before as well, this concept, very useful concept. So can we derive from here? What we can do over here is we can take something common over here. So if we take 10 to the square common over here, so what do we get? We get 10 to the power cube into A plus 10 to the power square into B, and we get 10 to the power 1 into C. Okay, or even if we want, we can take 10 cube as well. Let's take 10 cube. If we take 10 cube, let me erase this. So if we take 10 cube as power over here, so we have 10 square into A plus 10 into B plus C, and that's what we have over here as well. We have 10 square into A plus 10 into B plus C. 10 to the power is 1, so we can put C over here. See, identical over here. So again, let's go ahead one more step. So what do we get over here? We get C. Exactly. To the power C. Okay, so what do we get from here? What we can derive is, we can derive over here is, we can take 10 to the power A plus 10 to the power B. Now just what we can take, can you do this? It's 10 actually. You can take 10 to the power 10 square A. We can take this part is common. Let me just, this part is common over here. So if we take this part is common, this is what we get. What we get? 10 to the square plus 10B plus C, 1000 plus 1. You get it? Now let's go back to the question. It says a 3-digit number ABC has 3 factor. I'll just bifurcate it. Now it says ABC has 3 factor. It has 3 factors. So what does this mean? It means that we can write ABC in 10 to the power A plus 10B plus C, isn't it? Can we write it or not? We can write it. So can we write it ABC over here, and this is 1001. Okay, so can we write ABC if we do it 11 9 1 11 13 7. It should be 1001. I'm sorry, mistake. Yes, so 11 if you multiply 11 9 1, so 11. Okay, now again look at the question, because we have got the solution now. A 3-digit number ABC has 3 factors. Now see over here, how many factors is a 6-digit number over here? So this is a component. So how many factors you have? 1 1 1. So it's 2 into 2 into 2. Are we missing something? 13 into 11. Missing something. 11 multiply 11 9 9 1. Okay, let's do this. 1 0 1 0 0 1. So 11. 8 11. So 11 into 91, or yeah, or it could be 11. I'm sorry, 11 into 13 into 7. Can we get it? So 13 into 7 into 1. So what do we get over here? So we have over here 1 into 1 into 1 is equal to 16 factors. Now how do we get 16 again? Let me see. Let me explain to you. Let me see where I can delete this part. Okay, so I'll just do this again so that you can again follow me, because this is too much congested over here. Again, a 3-digit number. Now we need to see how much a 6-digit number ABC would have. So 6-digit number ABC can be written as, I'm just trying to be very much minded, I'm repeating everything. 10 to the power A plus 10 to the power 4 B plus 10 to the power cube C plus 10 to the power square ABC A plus 10 to the power 1 B plus 10 to the power 0 C. Okay, so what we can do over here, we can take common. We can take 10 to the power cube common, and we see 10 to the power square A plus 10 B plus C. That's what we have over here. So what do we get? We got this thing. If we can take common over here, 10 square A plus 10 B plus C, we get 10 cube plus 1, or 1000. So 10 square A plus 10B plus C, we get 1001. Now it says a 3-digit number has a 3-digit number ABC has 3 factors. 3 factors. So 3 factors. Let's say that number be, for example, PQR. PQR is 3 factors. So what does it mean? It means 10 square into P plus 10 square Q plus 10 Q plus 10 R. That's what we have. 3 factors means 10 to the power 0 R, 10 to the power 1 Q, and 10 to the power square R. These are 3 factors, isn't it? If you add it again, it will be a multiple of this, but that's none of the right now. We should not mind that. So this is what we have. So now we all know 1001. So now can we consider this as a BC one number, or we can consider this as let's say any number we can consider it, and we have 1001, which is 11 into 13 into 7. Okay, so this is one number, any one number, and this is another number. Okay, what we have broken over here into 11. So this is power 1, this is power 1, this is power 1, this is power 1. So total number of factor is 2 into 2 into 2 into 2 into 16. Now many of you might have inconvenience in understanding this part. So can we do over here, instead of over here, see these are common, so can we consider, let's say x equal to 10 square a plus 10b plus c. If we consider this, what we have, then from here we would get 10 to the power x into 10 to the power q plus 1. We would have x, and we would have into 11 into 13 into 17. Now calculate the total number of factor. It will be 16. Just for explanation, just for demo, you may do any way you want. Okay, so I hope again you would have learned something. You would have find this topic very interesting. This is a lot of applications, so therefore I have taken 3 separate videos for this. So in next class we'll be not doing this, of course. We'll be doing some division, and we'll see how division and cancellation can be made simple. Okay, so once again thank you so much for your time. My name is Prashant Mohan Thakur, and you are on competition.